All right, so welcome to LiveView.conf. It's been pretty good. Yeah. So we're talking about Phoenix LiveView again, and I'm going to make some bold claims today. So we'll talk about that in a moment. But I do think, compared to what we had last year, that I even more believe it's the correct way to go for a large class of applications. As always, before I get started, I have to plug Dockyard. Dockyard supports my work on working on Phoenix 75% of my time. And it's not only that, they're also supporting Paul with Distillery, and now Paul and Luke and Hans on the Lumen project. We're heavily investing back into the community, and that benefits all of us. So if you're interested in needing any Elixir help, we're full stack developers, design UXD. And as we like to say, when you're spending money with us, part of that is going back to directly support the tools that you're using. So you can be assured that that money is going directly back into making your products better. And I also got to plug the Phoenix Frenzy contest. This is a Phoenix LiveView contest where we want to showcase the world what LiveView is capable of. I have to plug the Dockyard team again, especially Nathan Long, that really headed up this initiative. Like, this has been a lot of work, so thank you. Like people dedicated their Dockyard Fridays for months to get this done across disciplines, design, project management, development. So this is out there, this is for the community, and there's still a month left, so there's plenty of time to check out LiveView and compete. It closes on September 30th, so check it out, and if you want to try to build something cool and submit it, it would be fun to see. That's at least how I live. I think Jose, Jim, and I live vicariously through the different LiveView examples that pop up. So I like waking up to a text from one of them of wow, check this out. So even just to make me happy, check this out. All right, so there's been some cool examples of LiveView in the wild. I was going to show those off. I want to make sure I respect people's time, but we've had everything from complete Tetris games. There's been a really cute hippo game that's been my favorite. Flappy Bird. Some really crazy games that you wouldn't think were possible. And then we've also seen some practical examples of just CRUD UIs completely done without JavaScript. So there's this LiveView collection Heroku app written in LiveView, which is pretty cool. Check that out for some really cool examples. And I also have to plug the Phoenix book. Thank you for being patient. This is slightly late. Maybe by 2 years, I don't remember at this point. But it's gone to production. So I have to say that Jose and Bruce, I really owe them also a huge thank you for really helping get this across the finish line. And we do have a 20% off code for the next several days. So if you want 20% off, check this on the video that's posted later. And we have to welcome a couple new Phoenix Core team members, Alex Garbe and Scott Newcomer. They definitely deserve some applause. So we're super excited to have their help. Alex gave a fantastic LiveView presentation yesterday, and then Scott has been maintaining the Morph DOM project and really being instrumentally helping out on the front-end LiveView side. So this is me a year ago, which is kind of crazy. So a year ago is when I unveiled and showed off LiveView. Oh no, uh-oh. You did it, you did it. I know what the fix is, but are we stable? Yeah, we're stable-ish. Okay, so we'll monitor the situation closely. So a year ago, I claimed this is rich user experiences without the complexity, and that the subtext is without the complexity of JavaScript, which has really resonated with people, it turns out. And I'm going to make some bold claims in this talk, and I just want to preface that again with the caveats and use cases. So again, I'm going to make some bold claims, and I want to say that the context of those claims is within these LiveView use cases. So we know where LiveView is a bad fit. So to make it clear, I'm just going to reiterate these points from last year. If you need offline support, sorry, you have to write code on the client. That's why we need to write code on the client. That's why the client runtimes exist. But with Lumen, maybe in the future we'll be able to write that in JavaScript. If you have high latency clients, you absolutely need to run code on the client. That's just the reality of the situation. Depending on your complex UI or native-like experiences, you may need to write a client-side app. It's hard to say case by case where that is, but definitely there is a line there, and we're still trying to find it on the LiveView side on how far can we go. Last year I said, could we build a full chat app? I wasn't sure. Now Alex and Chris Freeze in their training built a full chat app. So I think we can definitely build a chat app with LiveView and have it be a reasonably good solution. So we definitely know there's a point at which it stops working. We're still trying to find that point. But like I said, if you want no-fuss SEO, like if you don't want to have to like pay a service to render your HTML that is your JavaScript app just to send that to the client, like these insane complexity trees, just use LiveView. It just renders HTML. If you want minimal JS and payloads sent over across the wire, and as we'll see later, like payloads that are better than what you could write by hand, use LiveView. If you want to be really productive, which I think is what really has resonated with people, definitely LiveView wins in this case. So we've come a long way in a year. LiveView is actually officially released. If you missed that notice as of this past weekend, we are in Hex, and we've done a lot. Last year, our release, or it wasn't a release, what I showed off at ElixirConf was pretty much a prototype that, again, I started top down. Like, if I could just do this, it would be awesome. And then since it's Elixir, like it was reasonably awesome as is. But it had some super inefficient caveats there. So what we've done in the meantime is Jose came in and wrote the LiveEX engine, which Alex talked about yesterday, which allows us to do efficient change tracking and DOM diffing. So you just write the EX you're used to writing, and it becomes incredibly efficient. And we also have LiveView testing now. So there's LiveView test helpers that allow you actually to test this code that you're writing without having to spin up a headless WebKit browser. We have live navigation, which is a huge deal. So if you want to do push state on the client, update the URL bar without refreshing the page, that's a big deal, especially because people were previously building LiveView applications that had a bunch of state, and as you clicked around, if you shared a URL or refreshed the page, now you're back to some other state. So we want to be good web citizens. The goal is to build actually good experiences versus these unfortunate experiences we have with a lot of JavaScript applications that break in unexpected ways, render blank pages, the URLs don't take you where you expect them to go. LiveView with live navigation just works. We make it impossible for you to navigate to an invalid URL. We have prepend and append updates, which makes it efficient to add new elements to a page. So before this released, so before a week ago, if you had 100, so a lot of these are new features, so no one even knows about them. Not even some core team members up until a day before their training. But before, if you had 100 items, let's say that you wanted to render on a page, to render render one more item, you would have to store all those 100 items on the server memory and then send all 101 items back to the client just to add one thing. Like, that was a bad experience. So we fixed that. You don't have to store any state on the server, and we can still get the same kind of operations by using prepend operations. We have JavaScript hooks, which is also required for people. They need an escape hatch, and we have that, and I'm pretty happy with where it's at, and we'll see some examples of that. We have file upload soon. It didn't make it into this release, but Gary gave a great talk yesterday about how that works. It's definitely coming along, and it's insane. Like, if you've ever tried to do like get file progress as you're trying to upload something, that's a very difficult thing to get going. You have to bring in some JavaScript libraries, or like you used to drop a Flash plugin, right? Like, it's non-trivial, and even today, if you asked, I think the majority of web developers, hey, add the upload progress, it would be like, oh, let me go Google this. With Phoenix LiveView, it's going to be like 5 lines of code, like total, and you just like assign a % in a LiveView template, and you just have upload progress. It just works. And yeah, there you go. All right. And IE11 support is probably what you're clapping for. So this is actually, yeah, this is, yeah, so it turns out like I'm a JavaScript developer full-time now, mostly. So yeah, IE11 support is a less glamorous feature, but this is definitely required for a lot of people, supporting older browsers. So this took a lot longer than I expected. I was like, how hard can this be? It's pretty difficult. I don't know, anyway, yeah. You gotta run a VM, and then like your stack traces are like undefined object, no stack trace. So it's like, great, okay, anyway, so it worked. I figured out what all the errors were, and we figured out what polyfills are required. So if you have IE11 support, it should just work. If it doesn't, file a bug report. So one of the new features with, I mentioned was append and prepend. And we used to have this phx ignore annotation that allowed you to do your custom JavaScript operations, and we wouldn't touch that area of the page. So we have consolidated that to a phx update annotation. And this is what provides us the ability to, one, replace the content by default. So if you don't annotate anything, we always just replace new information or new page content. But we can now append and prepend, or if you're using jQuery plugins that like add a bunch of tabs or something that build their own DOM trees, you can mark a container as ignored, and then we won't touch it after we render it. So I want to show off how easy that is to use. So imagine we had this interface where we were showing a list of users on the page. Again, I talked about before how we had to store all that state on the server in memory. So if we had 1,000 users we wanted to show, then that's 1,000 users stored per LiveView in memory. That's not ideal. And then to add one more user, we would have to send all 101 users down to the client. Obviously not a good situation. So if you were writing an app like that, and it worked well enough because it's Elixir and it probably scaled reasonably well, now you can just say, okay, on that container, I'm going to do a phx update, append. So now anytime any content is added to this container, instead of replacing it, we're just going to append the new child nodes. And a feature we've had for a while that I don't think we've talked about is on a form submit, you can say phx disable with and get a little bit of optimistic UI. So we can say anytime a form submitted, we can instantaneously replace content. And in this case, you click more, so even on a highly latent connection, we're going to disable the form, replace the content of that button until the form submit is processed, and then it updates back to what it used to be. So in this case, we've got this very simple table with an append. We're going through however many users we have, rendering some TRTDs, and then we have a simple form that says anytime it's submitted, we're going to send the load more event to the server. So now back on the server side, because again, we don't want to store all 1,000 users we're showing in memory, we can now say our assigns can be temporary. And this name may be subject to change, but we'll figure it out. But the goal is, like I said, we have this information and LiveViews are stateful, which is great because we can do a lot of good things with the state that we'll talk about later. But a lot of that information we just want to render. And after we render it, we don't care. Right? There's no reason for us to have to get access to back to those users. And if we need access back to those users, we can always refetch them on demand. So we can say in mount, you know what? Please, Phoenix, after you render these users, like just throw them away. And then if I need them again later, I will reassign them and refetch them on demand. And then they're gone from memory. And the only thing that this LiveView is going to track in its own state is the current page that you're on and how many users to list per page. And this is the whole thing. Like this is the whole LiveView. So like after we mount, within mount we call fetch, which is just going to fetch some users from the database with pagination. We assign those users, and we have a handle event load more. So when that form is submitted, load more events going to be called, and we just update our page assign, and we refetch our information. And that's all we do. So it used to be where we would have to refetch all 101 users. Now we update the assigns with only the new users, and because we're appending content, only that one user, or sorry, those 10 users will be appended to the DOM. And that's it. So let's check that out in real life. So this isn't going to be nerves level demos, but I'll do my best here. All right, so I have this LiveView here, and I'm going to open up the web console. So it's exactly what we saw. We're listing some users. If I click more, it's going to add them. And then notice it was like a nice animation that's just CSS. So we don't have to write any JavaScript, just a CSS class. in our CSS file, and we get this super slick UI. And it happens fast enough on localhost that I don't even see the optimistic UI when I click this, but it disables to a loading state, and I can load my users and paginate. Yeah, okay, great. Cool, I didn't think that was clap-worthy, but still got it. All right, so the coolest thing about this is the data that we put on the wire. So this is where I'm going to stake some claims here, that if we check out the data that was actually written on the wire, it's still insane to me, even doing this day in, day out for a year. So every time we paginate here, I'm logging some debug information. So we rendered out a bunch of new table rows. There were TR, TDs, there was a CSS class attribute, and the only data that was written on the wire per page was somehow a list of strings of the only thing that matters to insert that new content. So the only thing that came over the network was somehow a payload better than the best handwritten single-page app payload that you could have written, unless you went to some esoteric encoding format where you no longer put any keys in your payload, and you somehow made the client and server aware of that per resource or page that or template you're writing. And we just got that for free by writing the most naive HTML possible into for comprehension with as much markup as we wanted, and somehow over the wire, a string of users came over. And this is what allows us, I think, to begin to take the lead on certain use cases. So last year, when I showed the 60 frame per second rainbow, we were sending a ton of data. Any little update would send a huge amount of data back to the page. Today, this is a demonstrably better wire payload than I think the best app you could write on a single page app. And for me, this is what is so exciting. Like, we can write, like I said, the most naive approach, and somehow it comes out to an optimal solution. So I like to say, like, last year, it was a worse is better example where we're like, yeah, this kind of sucks and is expensive, yet Elixir's good. Elixir is fast enough that it makes it viable. So for things that were like real-time validation on a form, like, people were getting value out of that. Worst is better approach. Like, it was better for some use cases. Now, like, it's just, this is better. Like, better is better. Like, demonstrably better than something I could write by hand. Like, it's just better. So if LiveView meets your use cases, with the caveats I talked about earlier, like, this is just going to be better than the best single page app you could write, as much as Gary on the core team likes to disagree with me. He's like, oh, I could just open my own WebSocket connection, and I would just define, like, you know, a protobuf protocol. And so maybe you could be as good as this, potentially. Maybe you could. But think about the amount of work, and think about, we get this for free. I didn't have to even define how to encode this data. I just wrote some markup, and bam, it was the best possible encoding that we could get. And it's going to get better. So today we encode that as JSON. We're working on an Erlang term format encoder where the payload would shrink even smaller on the wire. So that has me super excited. And like I said, it just works, and you don't have to think about it. And it turns out some people do need to write JavaScript, and that's okay. We need those escape hatches. So we have PHX hook binding now, which gives you JavaScript integration, and it's super simple. The goal is, again, not to create a client-side framework. So the Phoenix LiveView source is a single JavaScript file, so I think a lot of people that look at that, they'll open an issue like, this code is structured terribly, because there are like multiple classes in there. It's like 1,100 lines of code. And for me, it's intentional because it's a virtue signal to myself and the team that maybe if we need to have a huge amount of JavaScript files, we're accidentally going to create a 300 kilobyte JavaScript framework in our effort to not have to use a JavaScript framework. So our goal is to give you the basics, and if you need an escape hatch, then it's on you to write that escape hatch and do what you need to do. For example, controlled inputs is a term not everyone may be familiar with, but imagine you had a text input and your UX team said, you know what, as a user's typing, I want to automatically format that input. This is a terrible fit for LiveView because if you're expecting changes at the speed of users typing, you need 0 latency. You need code running on the client. So we give you that escape hatch. So all you have to do is say, okay, I've got this text input for a phone number. I'm going to add a PHX hook annotation to that DOM element, and I'm going to give it some name. So this hook is named phone number. Then I write a little bit of JavaScript, So in this case, I'm defining this hooks object, and it could be named anything, and I'm going to assign some named keys to that. In this case, it happens to match the phone number name. And then I pass that to the live socket constructor on line 13. So Phoenix knows when it adds an element to the DOM, when we patch the DOM, if it sees a hook, it will look to see, do you have a hook for this? And it will call this mounted callback. So on line 3, I'm just doing some standard JavaScript. I'm saying, okay, anytime a phone number, there could be multiple of them, anytime a hook is mounted to the page, I'm going to add an event listener to that element in that node in the DOM. And if it matches a certain pattern, I'm just going to replace the element's value. And the cool thing about this is this didn't have to tie back into Phoenix LiveView. I didn't have to say now, like, call some continuation. This is just, I set the element's value, it updated that. And the cool thing about this is if your form is tracking changes and sending them up to the server, it's going to, we're tracking them top level. So changing this input's value here isn't going to send the unchanged value and then send the new value. We're only ever going to get the value that you updated it to, because we're going to bubble up the event and catch your change value. So it works as you would expect without any fuss. You just write standard, nice JavaScript. And there's some other callbacks here. So in this case, I'm just highlighting, you can add a hook annotation to any container. So it wasn't just like a Phoenix form helper or HTML helper. This is just a div I can write. Let's say every time I have a comment here, I want to do something with that comment. And we have several callbacks. One is mounted, so this was added to the page. Anytime that DOM is patched and that node was updated, we call updated. If we remove that node, destroyed. If the parent LiveView disconnects, we allow you to do whatever you need. And if you are reconnected to the server, then we'll call that callback. And then the only minor difference here is we only call mounted one time. So even though technically if you lose connection on the server, you're going to have to call mount again and go back through that chain. But on the client, we have that DOM node still. So by using this approach, you avoid all these issues of like duplicate bindings. You don't have to worry about, have I added an event listener here? As long as it was mounted on the page and not removed, we will never call mount again. So you just write JavaScript. Like it's a term like, oh, sprinkles of JS. And I think we've all experienced like sprinkles of JS ends up turning into like sprinkles of jQuery or like query selectors on random IDs, and it becomes a mess. But in this case, like this is confined into JavaScript that's just scoped to certain DOM elements. You don't have to worry about trying to say, okay, get element by ID, some random thing I came up with, query selector, some random thing we came up with. You just write callbacks, and if Phoenix sees those hooks, it's going to call this code. So let's take a look at that. So I have another form here. We saw this last year, but now we have controlled inputs. So nothing too fancy, but imagine I just want to dasherize the phone number, and in this case, I happen to not care about international phone numbers. So as I type here, my phone number, it's not matching that expression, but if I hit 0, it automatically dasherizes that. And it did that on the client, and the server will have never received that 0 with no dashes. We change it, and then the value that gets sent back up to the server is the proper formatted value. So super basic, but people have needed this, and we give you that hook. But we can do more than that. So we saw on the first example that got claps, which was pretty cool, was, because it was pretty lame, so we have this list of users, and we can click a button and we can show more users. You're like, okay, that's cool. I mean, apparently that was cool, so cool. But imagine, like, wouldn't it be cool if we can do infinite scrolling? So regardless of how you feel about the UX of infinite scrolling, let's say, wouldn't it be cool? And this actually has been a big request for LiveView. And the nice thing about this is we were thinking about, like, do we need like a PHX scroll? And it's like we're trying, to be clear, we're trying to limit the number of PHX whatevers we have. They're all documented, but the nice thing is we waited on it till we got JavaScript hooks, and it turns out infinite scroll doesn't need to be some special LiveView library feature. It's like you can just write like a dozen lines of JavaScript, and like we didn't have to do anything. We had everything we needed. So we go back to that same template we had, and we add, I guess, 2 lines, but technically it just didn't fit on the page, so we just edit the existing lines. We add like half a line of code, and we say, we want to say on this table, PHX update is going to append, but now the hook is going to be named infinite scroll, and if I want to send data to that JavaScript callback, I can just annotate a data attribute. because since I have access to that DOM node, I can just put data there and read it back out. So now you can send events to these JavaScript callbacks just by annotating the DOM, and all of this is going to be change track on the server, and it's just going to work. So we're not going to be sending this data unnecessarily because everything is operating in the existing programming model. So I edited one line of code and said, okay, infinite scrolling, can't be that difficult, right? And then we wrote, technically it's 13 lines, I think I said 12. 12 sounds better, but we wrote a dozen lines of JavaScript. And we have a mounted callback, right? So this infinite scroll, this table gets mounted to the page, and then I say, okay, add an event listener for scroll. And I'm keeping track of the pending page because I don't want to say, as I'm scrolling, if I have a latent connection, since LiveView is so fast, we would end up like spamming like 1,000 messages, right? Saying like at 16 millisecond browser fire trigger intervals. So we want to say, as soon as we start, read the data set page value that we just assigned in the template. And we only want to say if we're not on the pending page. So if we can request the next page and our scroll percentage is greater than 90%, then we want to push an event to the server. So I left off this scroll function. It's 5 lines of JavaScript, but like cross-browser scroll percentage is like just what you would think it would be. Not that difficult, but it ruins my slide. So there are 5 more lines here that are what you exactly what you would expect. But as far as the Phoenix code is concerned, 12 lines of code, 13 lines of code. Okay. So we say as soon as we know that we can request a new page, we bump this pending value. So this is stateful, right? This callback is running. We can keep track of different values. And we know that anytime this DOM element is updated, so anytime that page attribute changes, that means morph_DOM is going to patch this DOM element, which means the updated callback is going to be called. And then we can just reread the data set, which is going to be the new page. And then this process just repeats. So any event listener is just going to keep firing, and we're never going to request a page until we've got the previous page we requested. And then that's it. That's all we need for infinite scrolling. And I have some highlighting here. Oh, I do want to talk about push event. So we do give you on line 8 here, let me go back. We do give you a push event primitive because it is useful to get data back up to the server. So just like you could do a phx click or a phx submit on a form, you can push events programmatically from your JavaScript code back up to the server, and spoiler alert, it gets handled in the same exact handle event callback, so we change no server code as far as the callbacks go on the server side. We just annotated our template. So let's take a look at that. So if I can go to, let's see here, new page. I think it's users auto scroll. I'll open up the inspector again because we can see the amount of data that we're sending. Okay, so I'm going to scroll, and I'll hit 90%, and it's going to paginate. And it's going to go as fast as I can never catch this. And the amount of data that we're sending on the wire, like I said, is tiny. And there's 1,000 users that I seeded, and it's paginating 20 at a time. And yeah, okay, so it's pretty cool, right? And the cool thing here is I wanted to, I texted Jose like when I built this infinite scroll, and I was like, hey, are you at a desktop? And he's like, no, I'm laying on my couch. And I was like, oh, no worries, I just wanted to show you something cool, like don't worry about it. And he's like, let's try it on my phone. So he checked it. I was tunneling localhost over to Poland from the US, and he said it was criminally smooth. Like, so on an iPhone, tunneling Wi-Fi localhost across the pond was super smooth. So this is incredible to me. And I think this is what sets us apart from single-page apps and other solutions that are trying to approximate what we've done here. So it's been great to see. We've seen other communities, be it PHP, Ruby, see these ideas and say, oh, it would be great if we could do this, which is awesome because that's essentially what we do too on our side, right? Like, oh, it'd be great if we could have this kind of feature that we've seen. But we can do this, we're uniquely suited to do this because of the platform that we're on. And I am not going to update Keybase, so please don't hack me. Okay, so pretty cool. And I have do not disturb on, that shouldn't have happened. So one of the big features that actually took a lot longer than I thought in retrospect was live navigation. So it was like, again, I wasn't a JavaScript developer day in, day out, which I've been for the last year, but I was like, push state, how hard can it be? It can't be that difficult. It was pretty difficult. So what we've done is, so if you're not familiar with the term push state, it's just a way that you can, from the JavaScript side, update the URL bar without changing the page. And it's just called push state, which still is perplexing to me, but it updates the URL bar potentially with some metadata. So we want to hook into that with LiveView because a lot of times you want to be able to, again, like I said, be a good web citizen. People were writing LiveViews that were allowing you to paginate data, sort data in a certain way, and it was really compelling, but all that state that should have been in the URL bar for refreshes, for shareable URLs was just lost. So again, our goal is to write compelling, nice applications that avoid all these caveats. So live link and live redirect is a way for us to properly handle push state navigation, and we make it impossible to do it the wrong way. So there's no way that you can accidentally create a bug where you can update the URL bar to something that will then be the wrong state or go to a different live view or be an unreachable URL, which is pretty neat. So you can use these features, which are great, and you can't use them. You can only use them in a way that will get you back to where you were if you lose connection, if you have to refresh the page, if you want to share the URL. So you can do that with using the live macro in the router. So instead of like get to users, I can say live at this path, and I can route directly to the live view. And then in my live view, we have a new callback called handle params. So it's mount like you were expecting. If we want to just, let's say, just add pagination with a good UI that it's not infinite scrolling, it's just next page, next page. We add a handle params callback. And handle params is interesting because we were able to consolidate multiple code paths into one. So what happens initially is mount gets called, and let's say you care about what the current page is in the path params. We're going to immediately call handle params after mount and say, okay, here are the params we have. Whether they're the query string params, whether they're the name param, path params that you had, here they are. So it gives you a chance to react to those because that's going to affect the kind of data that you're showing on the page, right? If you're on page 5, you want to fetch page 5 users. So we fetch those users, and then we render that page. But there's a separate step here because as we're clicking on the page, let's say we want to go to the next page. Well, now we have this case of if I click next page, I don't want to have to kill that live view, throw away its state, remount the live view, recall handle params. It's like I have a running process on the server that has all the state that matters about showing a page, like the current user, their current preferences, their content preferences. I should just be able to update the URL bar with push state and then send a message back to that live view to say, hey, the params changed, you need to react to this. So it turns out that's exactly what we do. So initially, mount, immediately call handle params. Optional, it's an optional callback. We fetch our data, we assign to the socket as we're used to, and the UI gets sent down to the client. And then the next step of once we have a stateful process is we have a live link helper. So you used to have, or you still have a link to, so link next to. Now you can just change it to live link next to. And this means we're going to use push state on the client. And instead of going to a new page, throwing away that state, we just re-invoke handle params. So the running live view for what it means to show a page of data has its handle params callback called. Params has the new params that were pushed via push state. You refetch your data, update the assigns, and the UI is going to update. So we went from this. So the programming model here is coalesced to one callback, and it does just what you would expect. So let's check this out. So again, if you wanted just to paginate data in a normal, nice way, we have this live view here. And when I click next, instead of throwing away that page, killing that live view, doing an HTTP request, completing the HTTP request, doing a WebSocket request, updating the live view just to show the same state, we just click next, and we're going to, it's tiny font, so I apologize, but we're going to update the page 2. And it's going to be ridiculous. I mean, it's on localhost, but it's going to be ridiculously fast because we're operating over this existing WebSocket connection using push state. And notice now I'm on page 12. So if I share this URL or I refresh, hey, it looks exactly the same because that's how it's supposed to work. And we enforce this because, again, like I said, we make it impossible to get into a bad link state. But that's not the end of the story, because we could also do live redirects from the server. So obviously, I mentioned that live link is push state on the client. Push state is a JavaScript browser feature. So we need a way to redirect from the server that also uses push state. So we have that built in, and we call it live redirecting. So imagine we get this request that a client says, hey, wouldn't it be nice if I used the left arrow, right arrows to do next page or cycle through the next image? It's like, hey, we can do that. We have the technology. So I'm going to add that feature. So what we would start with is, if we go back to our template for this, I can go to index.html, live.ex. I have a table. And what we've seen before with Phoenix bindings, or maybe you haven't seen, is I can annotate this. So I can say phx key down, and I'm going to send an event to the server. I'm going to name it key down in this case. And since this is a DOM element, not an input element, like normally tables don't listen for input elements, I can give it a targeted window to say, I actually want you to apply this key down event listener to the window object. That way I just want to capture all key presses on the page. So I do that, and the page probably refreshed because of live reload. It did. So now if I try this, it's like, oh, it blows up, right? Because I haven't implemented a callback. But if you notice, it recovers because it should, just like an Elixir app. So we need to implement these callbacks, right? So it's sending these events when I hit left and right, but nothing is working. But it recovered, and notice the content still worked, right? We're still on page 12, even though we haven't refreshed the page, because again, the model enforces that these things work as you would expect. So I'm going to go back to our template code and write a little bit of Elixir. So yeah, I'm on user index. That's where I want to be. So let's say I'm going to receive a handle event. We called it key press. Key down. Oh my gosh, that would have been disaster. Okay, so in this case, a new feature is we always send maps now to handle event. So it used to be we only sent the key code, but some people said, well, I want to know if the meta key was held, and then other requirements were like, I want to know if there's like 17 attributes. So we decided that we're going to always send a map to your hand event callback, and we're going to send every object literal value of that event that's relevant. So now if a key press event listener is fired, you get that as an Elixir, or as a params map. So I happen to know that the code attribute of that event listener in the JavaScript side gets sent to me, and it's going to contain like arrow left of the description of the key. That's nothing that Phoenix added. That's just if you did a inspect on the JavaScript console for a key down event, you would see this map of data. So I get my socket and a callback. And I know I also need another callback for key or arrow right. And within these callbacks, I need to do some live redirection. So to do live redirect, it's super simple. In this case, I'm going to write a shared function. So I can say, OK, I don't need to reply, and I'm going to go to a certain page. So I can say, given the socket and the socket assigns .page value. If you're going left, that means you're going back, so it's going to be -1. If you're going right, that means you're going forward, +1. And I'm going to write a function now to go to a page. And we know in this case, like if someone's going back and they're on page 0, we don't want to continue to go back. So I can say when the page is greater than 0 is the only time I actually want to do live redirecting. And when the page, and this is going to take the socket as well. And when the page is not greater than 0, then I know I'm in a bad state, so I'm just going to return the socket because I'm not going to live redirect beyond the first page. So, okay, so the last thing is, okay, let's do a live redirect. And it turns out it's just live redirect. So just like we have link to and live link to, and just like we have redirect to, you can say, okay, I want to make this a live redirect to. Both work. If you want to use push state, you use live. So I can say live redirect this socket, and I want to go to the routes dots, I think live path. And I give it my socket. The current LiveView module is what I was routing to with the live macro in the router, so that's where I want to go. It's a named, it takes a name parameter called page in this case, but we don't want to send it as a query string parameter. We want it to be inserted as a path param. So I think this will work. Let's find out. The page refreshed automatically, or should have, so it compiled at least. And if I hit left and right, now the page is going to change. So pretty cool, right? And I'm going to talk a little bit about what's coming very, very soon. But what is coming very soon, people have asked me today, is debouncing. So currently, we don't support debouncing. You have to write it yourself. So if I hold down the right arrow, I'm going to paginate very quickly, right? So so we're going to add debouncing, so this wouldn't happen. Key repeats wouldn't happen, or you could say I only want to send this event every X amount of seconds. But the crazy thing with this is, like, we're hitting Postgres on every call here, right? Like look at this. Like, it's ridiculous, right? This is like, I don't understand. All right. I crashed it somehow. OK, so pretty cool. So that's live link, handle params. There's a live redirect that I added, live coding. But let's talk about like why was I able just to do like page navigation at the speed of as fast as the browser could send the key press event. It's because we have this model, and this is why I'm going to again stake the claim that I think for certain use cases, pagination, infinite scrolling, applications that don't have the caveats, like I said, of trying to build these desktop-like experiences, I think we're going to be demonstrably better for a lot of these use cases. And the reason why I can make that claim is if we imagine how the existing model works. So you write a single-page app, whether you're talking JSON API, maybe you're talking GraphQL, you're going to have to operate over HTTP unless you want to roll your own WebSocket API. Let's talk about the existing model. Folks talk over HTTP. They say single-page apps are great because we don't have all this overhead of re-rendering a page. So cool, let's write this over JavaScript and HTTP. So what I have to do is send a GET request to the server. I send a bunch of headers that we don't think about, right? I can send the accept header, hey, this is a JSON request. And oh, by the way, here's my entire cookie session, up to 4 kilobytes for every single request. Oh, by the way, it's encoded. So the server's gonna have to do some work when you get it. So we go through, okay, we hit the endpoint, we've decoded the headers, cool. We made it from the web server underneath. Phoenix endpoint gets called. We immediately hit plug parsers. We do some cryptography work to verify that signed cookie. We decode it back into the session. It's like, okay, we know who the user is now, cool. And then you're like, okay, call the router. And now we have to hit the database to get the user. Because again, every page that you go to next page, we don't know who the user is. So HTTP is stateless. So I think a lot of us, even myself included, we are so used to the web and the stateless HTTP model that we don't think about like kind of how crazy it is that we do all this work and we forget it all just to do it all again. So every page, okay, fetch the user again, even though we just knew who they were 10 seconds ago, go fetch them because we forgot. Now we hit the controller and like, okay, well, we had their interest on the last page, but again, we threw that away. So fetch their interest so we could render the proper content for them, their friends that they're following, and render that content back to the client. And okay, write some JavaScript view. We have to figure out how we want the payload to look. Maybe it's using JSON API. Maybe it's a GraphQL schema, whatever it is, encode that, define that schema on the server, send it back to the client, 200 response. Okay, cool. That page is rendered. And I think we trick ourselves into thinking like, this is fine, this is cool. But again, like I said, you're writing all this JavaScript under this illusion that it's superior because we can keep the state on the client and not have to refresh the page. But we still have all the overhead of HTTP, right? It's this model of like, okay, get the user, start a process, cool, concurrency, decode the session, fetch a current user, and then we just like put a jetpack on the process and like rocket it into the trash can as fast as we can, right? Like that's literally the goal, right? Like most web frameworks, right? Like especially coming from other platforms, like literally the goal, like this was a literal goal, like you get rid of the web request as fast as humanly possible because you don't want to block. So at least with Elixir, we have the benefit of being able to take advantage of this concurrency, do the work that we need to do, and then just rocket into the trash can, even though we know we're going to use it later. So we throw that away on the server as fast as we can, and then we still have to do extra work. We have to re-encode the session. So we do a set cookie header, but it's going to be encoded. So do some cryptography work again, send it back, and there's like a joke in here. So I was like, well, what cookies could I come up with? And the ones I came up with like were like remember me and like GDPR accepted. And the hilarious thing here is like you know, there's always like you log in, you're like, keep me signed in. Like literally the names of those that I've written in past apps is like remember me. And it's like the client is literally sending up a cookie every time, remember me, and we're like, cool, I'll remember you. And then like we throw it all the way back to them, right? Like it doesn't make sense. But that's what we do. And if we're not running a client-side app, some of us are, because we want these certain benefits. If we're not running a client-side app, then the client kind of brings up its own trash can and gets its shovel out, and it's like, okay, that 20,000 lines of JavaScript, like, get that out of here. I don't need this again, even though you're going to need it in 10 seconds. So it's kind of crazy. And we're able to sidestep all of this with LiveView, right? So we get the best of what the client-side frameworks are pitching from, hey, we don't have to reevaluate all this JavaScript every time for the browser to, you know, parse 100,000 lines, even though that's gotten fast. We can just load it once, we can load the CSS once, and we patch the DOM as needed. So we get all those benefits with live navigation without all this caveats of like what other frameworks are doing, where you can say, hey, we also can do live quote unquote navigation, but they're still using HTTP behind the scenes and just replacing the body. So they're still doing all this cookie work, all this header work, throwing away the state every time, just to refetch the current user, just to refresh their preferences. It's like we have a stateful system. We can hang on to the state we care about, and that's what allows us to see like those insane updates, those insane speed times coming back, because this programming model allows it. So that's why I'm staking the claim that for some use cases, unless you want to write an insane amount of code, you are not going to be able to beat what we provide out of the box, and you write it in the most trivial way possible, and somehow it gives you an optimal solution. And to me, that's the most compelling part of LiveView. The fact that we don't have to write JavaScript just happens to be a nice icing on the cake, right? All right, so what's coming soon? So soon as in, like, this is what we're prioritizing next. So it is a release on Hex, please use it. I forgot to ask, who is using LiveView in production? Can anyone? All right, that's actually quite a few people, so as a Git dependency, so cool. Check it out, it's on Hex now if you didn't see. It turns out everyone here, or everyone by proxy here, has used LiveView in production as a user. The ElixirConf website checkout ticketing system was like one of our first real production uses that Jim wrote. And so you use the LiveView system, you didn't realize it, and you all showed up, so it worked. So cool. Good job, Jim. All right, so yeah. Clap, yeah, great. And yeah, I don't know where Jim is, but he also, like, he's had like no problems. It's been like one of those like rock solid, you're like, okay, all right, Jim, like, you know, I hope this works because we want people to show up here. And it's been a super smooth, rock solid experience, which is awesome. And he built it in an insane amount, a short amount of time. And the experience that he was able to build is more compelling than, you know, these other competing platforms that are probably using JavaScript frameworks. All right, so what's coming soon? And like I said, this is just what the Phoenix team is focusing on. I expect these things to come quickly. I'm not going to put a timestamp on them. It's going to be far less than a year. It's going to be, but now that we have the building blocks in place, you're going to start seeing user-land features at a much faster pace. So debouncing, like I mentioned, most requested feature, definitely needed. We'll be there very soon. Exception translation is something that we want to work on. Currently today, if you raise an exception in the initial HTTP request, like ecto no result error, not found error, we know how to translate that, and Phoenix translates that to 404 or 400 or what have you via the plug status protocol. But if you're coming over WebSockets and you raise the same exception, that's just going to crash the WebSocket. So we want to be able to say, if we know that we would have translated this to an error that we will have responded in a certain way over HTTP, we just want to redirect and have that same experience. So that is coming soon as well. File uploads that Gary showed off yesterday, I'm super excited about that. That's coming very soon as well. I haven't mentioned Stash on the client side for storing client-side state, but there is a way, you can do it today. If you need to have the client hold on to state, let's say for disconnects that are happening, if they drive under a tunnel, if the LiveView crashes, you can do that today, but you have to write a little bit of JavaScript to make that happen. So we want to make that easier and automatic with this idea of, we're calling it a stash now, and the naming is subject to change. And what that will enable us to do is automatic form recovery. So today, you can get automatic form recovery, let's say if you drive under a tunnel, or the LiveView crashes, or you do a cold restart across the cluster, you can get form recovery, but it's not automatic. You have to write maybe 20 lines of JavaScript to have the client send their current values back up when they reconnect. We want to do that automatically if we can detect that we can recover. So this isn't going to work if you have complex multi-step forms that, depending on the step that the user was on and the current database values and your current business logic, you may not be able to recover based on what the client has on their page. So for very complex forms, you can write a little bit of JavaScript and recover from that stashed information, but you may have to write some business logic around. Let's say you push a change and the old form now is rendering new inputs or remove those inputs. You may have to manage that version change yourself, but for, I think, the majority of forms, Phoenix will be able to detect, oh, we know that these same inputs are here, so we're going to automatically recover for you. So we'd like to get that soon as well. So for pre-1.0, I don't have a time frame on this, and I'm not going to rush this because we want to make sure, I think we've nailed the programming model. It's clear that we're onto something here, but I just have some ideas that I want to explore, and we're going to take our time with these ideas. They aren't necessarily going to make it to 1.0. We may decide that we can punt, but one of the big things is intelligent collections. We have append and prepend, we have the building blocks, but we may make it even easier for you to say, oh, I just want to add something to this collection, and you don't have to necessarily worry about updating the previous values. So just kind of building on top of the building blocks that we have. And kind of the biggest thing that I think we need to solve and want to solve is acknowledgement-based updates. So currently today, if you submit a form over a LiveView, you click something that you expect some side effect to happen on the server. It's possible that there's an in-flight update coming to the DOM that's going to be an unexpected experience for the user, right? They're waiting on something that that happened when they click this. That's going to be processed by the server. We're going to update and patch the DOM properly, but in the meantime, they may see their UI update in an unexpected way, right? So what we're going to do is try to wait for an acknowledgement from the server for that area of the DOM and queue up those patches until we know that the server has processed them, the server has sent us the diff, reapply those patches so it works as the user would expect and as you would expect for more latent connections. So that's a big feature, and it's going to take some thinking and some work, but that's something that I would really like to land before we're ready to say, okay, this is 1.0. But the thing for me about this whole journey of like from last year where it was like, this is insanely compelling, I could use this for so many things today, even though I implemented it in a not great way, not efficient way, and where we're at now where I think this is demonstrably better in some cases versus a client-side app, is like it's what I like to say is like it feels like cheating, and I'm stealing this. I think I'm stealing it from Jim, where we can say like Elixir, it feels like cheating. Like with LiveView, like there's like as we like to text each other about these LiveView demos, but like so that's always fun. And then while Jim was building the ElixirConf checkout system, like he literally said like it feels like cheating. Like he's like the speed that he was developing these features, the fact that this was working somehow and working well felt like cheating to him. Which is awesome to hear, right? It makes me smile. But then, like, I felt this feeling a week ago, which is crazy. So as an implementer, I think this has happened to me multiple times. I think it was like with channels and now with LiveView, where I've implemented an abstraction. So like down to the lowest levels, I understand how LiveView works, and then I go back as a user, and then like I blow my own mind, and that's like that's when I think that's when you know you're onto something, right? So I think. That happened to me. It had been a while. I've been writing a bunch of JavaScript, been in the weeds on the Elixir side as well, and I put training together for LiveView a week ago, and I just built a basic thing to teach the concepts. So I was like, okay, I need to build it had been a while since I just put a basic thing together. So I was like, okay, I need a CRUD interface. I want to be able to edit some tabular data, and like I just wrote like an if, and then like, okay, if I know that the thing that I'm focusing on is this, render a table row, else render a Phoenix form with a submit, and I can save the information. And like live reload, like I tabbed back to the browser, it was there, I clicked edit and like boop, the form showed up, and it was like, I literally was like, what is going on? Like, how does this work? So to me, I feel like this happens over and over in Elixir. Like it feels like cheating. Like even as like the implementer of the abstractions, it's like, how is this working so well? And I think Jose touched on this yesterday where even with like scaling Phoenix channels where I did a best effort approach with help from the team, about how the channel's architecture. We benchmarked it, and it's like, oh, 30,000 connections. Like, oh, that kind of sucks, not great. I guess I'm not a good developer. And then we opened up the Observer, like, oh, what are we going to do now? Like, well, let's see what Observer tells us. Like as Jose said yesterday, we ordered by message queue. Like, oh, there's the bottleneck. And like we changed literally 10 lines of code, 2 million users. Like, it's like, what? Like, I guess I am good. Like that, 10 lines of code. Like, and that felt like cheating, right? So I feel like this concept, it keeps happening over and over, and I keep waiting for it to stop, right? And like whether it's LiveView or any other Phoenix or Elixir feature, it's something that is a pleasant surprise, and I think that we should all kind of internalize that. It allows us to do things that we didn't think we could do. So with that, thank you all very much, and appreciate it.